Hello world, my name is Michael and welcome to I'm a Teapot. I'm joined here today with Sebastian.
Hello.
Hi Sebastian.
Let's just dive into it. Michael, what's the technologies you're looking forward to work with this year? What is exciting you?
So this year, I think I'm on a bit of a performance kick. I'm very excited about anything that's increasing my performance, the performance or my developer experience. So I think like the first thing I'm really excited about is Vit. And we have to remember to call it Vit, not some other name, otherwise Tatiana will kill us. But Vit, it's like a replacement for Webpack, and I find it fascinating because of the way it approaches speeding. I mean, like most of the other things, I wrote an article about this. They are taking the approach of like ditching JavaScript and going to Rust, going to Go, or whatever. But Vit also, okay, fine. To be fair, Vit does take this approach as well, but as a whole, it also takes a very clean approach where it's still written in TypeScript and JavaScript. For most of it delegates building to ES build, which is written in Go, but that's another story altogether. But then it just starts cutting like stuff which it no longer needs. And I think that's a very cool thought because browsers have been improving for years now. I mean, browsers now support ES modules, browsers have got native whatever support. Vit takes advantage of that because Webpack didn't. And I think that's one of the things I like really am excited about. So I'm actually playing around with Vit.
Didn't and couldn't, right? To be fair,
yeah.
Because I think the browser landscape became a lot more, let's say, standardized.
Very true.
Probably still not great, but like much better. It's definitely since Internet Explorer, I think 4 or what was the worst nightmare with this?
Oh, Internet Explorer
it's definitely
must
increasing.
Die. I am so glad it died. I'm so glad. That's the one death I celebrated. Oh my God. Internet Explorer was a nightmare. It was a nightmare to work
dark
with.
very quickly from a positive.
No. The death of Internet Explorer is not dark. It's something that should be rejoiced. Okay. So aside from Vit, the next thing I like is what Vercel is doing with NextJS version 13 and friends. So like I think we talked about this in one of our earlier podcasts when I went to the React config, and I was excited about stuff like the server-side components, the streaming data and all that. And then I think you were like, so can you use that right now? I'm like, no, it's mostly in alpha. It's coming in the future. The future is today. We've got all of that stuff in next version 13. So it's awesome. But they are still prefacing it with just be careful. We're no longer in alpha, but we're in beta. So just be careful. But I'm going all out on that. I'm like updating my own personal site to use all of the new goodies. I'm very excited.
You have one example for us, or one, I don't know, thing that bothered you in the past, or something new you look forward to, like, trying out?
When developing, I always like one of the things that really bothered me is when you make changes and then you have to wait for a few seconds for it to change. So sometimes, depending on how much changes you made before you press that save button, you might be waiting for a few seconds to 10, 15, and then that's all the more time or opportunity for you to get distracted. So this new thing, for example, Vit does this, and the new 13, they update ridiculously fast to the point where you're just leaving the IDE and you're just looking, it's done. Instead of
you mean the hot reloading of changes in the browser, right? For stupid backend developers. Okay, yeah. I agree. Like, having seen the switch and a new project from Webpack toolchain to Vit.
It's unbelievable.
It's just, it's too fast in a way.
I know.
Because you think it's broken.
You don't trust it.
That's great.
You don't trust it. You'd be like, okay, there's something wrong here. Why? It shouldn't be this fast. And that is an amazing something
it's like when you don't have to wait for an elevator, never. It's kind of weird, right?
I know. or that case where you're driving and all of the lights are just green is the moment you arrive. You begin to think something's definitely wrong here. That's what I feel about. That's how I feel about this. So yeah, and it's just stuff like that. I mean, we're going front end is really focusing on improving the developer experience, the CI/CD experience, and I cannot be more excited about that. I mean, like, in front end, that's
I agree.
my thing.
I think it really became, I mean, to be honest, a real pain. Like, you know, like you had like front end pipelines, they were taking like the majority of your patient, essentially. Like, we're talking minutes to hours here easily, right? And it's just I mean, there's reasons for everything, but we're talking here a tenfold, right? At least an order of magnitude of speed increase.
Yeah.
So stuff that took 10 minutes is now a minute, or stuff that took a minute is now a couple of seconds.
Very
so it's
true.
not a little.
You're absolutely right that sometimes the pipeline on front end was a nightmare, because I remember in one of our old projects, we had like a note in it that when you start this process, then you go get a cup of coffee, because it just took that long. You could go brew a cup of coffee, come back, and thing is still running. But now you don't even have time for coffee. You can't even go get a glass of water anymore. I mean, like, that's a good thing. It's ridiculously fast, but it's really bad on my water intake now. But yeah, that's what I'm excited about. How about you, Sebastian? What are you excited about this year?
Yeah, so I think speed, and in particular increasing of like responsiveness, or like like faster iteration cycles. I think that's a really interesting and also general topic you were describing. So I think in compiled language, people talk about it as well, like Go, C++ had this discussion. I mean, our focus is about producing fast code, but it doesn't matter if it takes I think if you compile Chrome or the Linux kernel, the coffee is a gentle example. It can take days or like at least hours to compile. And of course, there's mechanisms. But like one thing I found out interesting when we go back to scripting languages, right? Our beloved language Python, right? In the backend, there's also recently a focus of saying it's not only readability, and actually, I mean, Python is fast as a scripted language because, I mean, you start the interpreter and then responsiveness is there, but like saying, okay, I mean, it's fine, but like we also want this loop to run faster, or this data access to become faster. So there's recently a slight shift or shift is not the right word. There is some focus put to not only readability and joy of programming, but to also have it fast. Which, it's kind of interesting because I had the thought, I mean, in the past, right, when we had single cores and like we had Moore's law at its finest, you didn't have to do much. Like everything you were struggling with a year ago, squeeze the last thing off, have the like high-end graphic card on games or something. Now like you just had to wait a year or 2 years, and then like it's a bit exaggerated, but almost like every trash computer could run it, right? And these times are like definitely over, right? Like iterations, I don't know, if new consoles are longer, computer, I mean, it's not like there's no innovation anymore, but it's definitely not single core performance where you do not have to do anything. You can, of course, the next iteration of programs, games, languages can take care of it. But it needs work. So people turn to actually, I mean, as for tools where it really didn't matter, like this. But now it's actually so broadly used. I mean, I think it's also a matter of scale. I mean, Python is now everywhere. Used to be kind of. Sorry, go on.
No worries. I think what you're saying is actually pretty accurate. I think before we used to solve all of our problems by just throwing performance at it, but we've reached the point where more performance doesn't really solve the problem anymore. So we were now sort of like having to focus on improving efficiency with all of this performance we have, because no matter how much performance we're throwing at it, it's not solving the issue. We've gotten to the point of performance saturation, if that's such. Is that even a phrase?
I mean, as I said, I mean, I think for single core, if you add single core or so in there, that's definitely true, and it's true for I would have said a decade, but that's maybe too much, but definitely several years. And that's, I mean, that's interesting. And yeah, I'm not sure. I mean, of course, there's also danger. I mean, there is a reason why we moved away from assembler. Like, so right? This is kind of going back full circle again. I think we said that phrase several times in the podcast. But, obviously, in the beginning, you had to be performant because otherwise it was just too slow to do anything. And then, this room started because computer became just so fast. You think, Michael? Sorry.
No. I think that I think I mentioned this in one of our previous podcasts, but the history of computers and computing and development in general is a circle, because we always like come up with this brilliant idea, then we come up with a better idea, come up with an even better idea, then come up with a fourth brilliant idea, which is exactly the same as the first one, and then we just keep rotating like that.
Yeah, I mean, there's the other sentence, and I think that kind of explains why it's not only, it's kind of a spiral, probably, I would say. I know someone that likes that sentence, but it's too much of an insider. It's a spiral in the sense that I think there isn't a problem, right? That's the other saying in computer science that you can't solve by adding another layer of abstraction. And I think that's exactly how your circles can be explained. Yeah, you kind of do assembler, then you're saying, oh my God, that is like just unreadable, unusable. I do something like C because, and I define something like a operating system, a driver. So you add layers of abstractions to make it easier. Well, and now we go like 20, 30 years, right? We have the web, we have databases, we have software as a services, we have front end, we have back end. So we go kind of, I'm thinking of like, you really have like nowadays 20, 50, 100 layers, 100 layer of abstractions between.
Way too many layers.
But I don't know. Like, I mean, it makes your life easier, right? Imagine you have to do in assembler what you wanted to do with NextJS on your website.
It does make your life easier. However, what we're seeing now is the event where, because like we've reached a ceiling with one particular type of architecture, we're switching to another type of architecture, which means the bottom layer now needs to change, and it disrupts everything. I mean, it's not so bad when you have like 5, 6 layers. When you have 20 layers, that just kills everything going up.
Maybe. Or you can replace it. But I think, like, to get back to your thought, I think that's true. But that's why these circles come, right? You kind of see that your current layer, you have that, right? JavaScript was like you click the button, you want to turn it red. Okay, fine. Then it got more. Then you realize, okay, maybe we need some tooling. Maybe we need to compile something. It doesn't make sense to compile JavaScript. I mean, it does, but like the thought, right? So you add actually the ideas and like solutions that got established. I mean, not the same one, but the idea. I think you transfer the idea from the lower layers to the upper layers, because if it worked there, let's see if we can adapt it. I mean, there's some danger, but it's also relatively clever and, I mean, in a way, nice thing to do, because you kind of learn from the past, right? From what people did before. I think, I hope that's the case. Let's put it this way. I think there might also be the case where people forget if it's, I mean, like, from other sciences or from longer, like, I mean, if the circles become longer than lifetime, which is in computer science, it's starting to be the case, right? People might also forget and reinvent and make the same mistake or even worse mistakes because, but I think you can learn a lot from looking back and...
looking back. Yeah, I actually think so. I think one of my favorite books was written a very long time ago. They released a recent version, but I actually preferred the older one. I mean, that is the same book. But back then, just looking at it and then reading through it, and you'd be like, oh, okay, cool. And I think in the new one, he mentioned something like, okay, we had this example where we wanted to write a video recording, a video rental system. But then if we put that example in the new edition, all of the people asked, okay, first question, what's a video? What's a video tape or something like that? So yeah, but it was like, I'm bringing it up because it was a very interesting insight into which is basically my childhood, because I think I'm really old. the way
what book was people, it? Can you
The Pragmatic Programmer.
Okay.
Yeah. Pragmatic Programmer.
And was it a language specific, or was it more like
it's not so much language specific. It's more about the qualities that a good developer should have, you know. How to be a better engineer, basically.
Yeah.
It's a good read. The first one did it in some old language I forgot. The new one did it in JavaScript. Yay. So but it's not specific to the language itself. It's a good read. I recommend it.
I think that's a very nice wrap up. So we have like stuff we're excited about, and we have books from the past that are still recent and important. We have as a recommendation to read this year. I think with this, thanks a lot, Michael, for the first episode of 2023.
No worries. I have to say thanks for having the time, man. Because I know you are way busier than I am.
That's all relative, right? I really enjoyed, and I hope our audience enjoyed as well. See you next time.
See you next time. Bye-bye.